Hi guys, welcome to your screencast on the adaptations of the cardiovascular system. So we've already looked at the responses, now it's the adaptations. Okay, so you need to understand that if you undertake a purposeful kind of exercise program, your cardiovascular system will adapt over time. Okay, the main reason we want our cardiovascular system to adapt is essentially so that we can get oxygen to the working muscles and remove carbon dioxide at a faster, quicker, more appropriate rate, basically. So we have a number of adaptations that take place. So what I want you to do is, first of all, get those adaptations down. Okay, so we have cardiac hypertrophy. Now you have to understand cardiac hypertrophy. I'll go into this in a bit more detail, but cardiac hypertrophy is when the heart grows in size and strength, basically, specifically the left ventricle has hypertrophy happen to it, so it becomes stronger. Now you have to understand this is linked 100% to an increase in stroke volume, i.e. the amount of blood that leaves the heart per beat, and it's also linked to a decrease in resting heart rate, i.e. the heart doesn't have to beat as much because it's bigger, it's stronger, it's forcing out more blood with each beat, which reduces our resting heart rate. We also have a reduction in blood pressure, capillarization of skeletal muscle and capillarization of alveoli, and we also get an increase in blood volume. Now, when it comes to adaptations, it may ask you specifically just to discuss cardiac hypertrophy, it may ask you to discuss capillarization of skeletal muscle and alveoli. It may actually ask you to discuss all of them. So it is quite this is quite difficult, and we've got a memory method to use that hopefully help you with this, but you have to bear with me with the memory method. Some of you won't get it, won't like it, and you do not have to use it. For others it may work, and that is exactly why I'm showing it to you. Okay, first of all, cardiac hypertrophy, I've just gone over what it is. It's the enlargement of your heart over a long period of time. The wall of the left ventricle thickens. You can see this is hypertrophy, this is not hypertrophy. So what happens is every time this contracts, it's more forceful, it's stronger, i.e. more blood is going to be able to leave the heart per beat. So that has an effect on our increase in resting and exercise stroke volume, i.e. the amount of blood that leaves the heart per beat. That's going to increase because we've got an increase in cardiac hypertrophy, i.e. the heart walls are stronger. So that's going to have an increase in stroke volume. What else is going to affect stroke volume is, and this is the main thing, is venous return. Okay, so stroke volume is dependent on venous return. This is the amount of blood going back to the heart. Now, what's really important to know is, with exercise, we get more blood going back to the heart, okay? And you've got to think, one of the other adaptations was blood volume, i.e. the amount of blood we have, there's more of it after an adaptation to cardiovascular training. This is really important because it's quite difficult, but as long as you get the process, it's understandable. So venous return is the amount of blood coming back to the left, to the heart is venous return. The amount of blood coming back to the heart. Venous, veins, returning blood to the heart, venous return. Now, we get increased venous return with exercise. Now, there's something called Starling's law. Starling's law, all that suggests is when more blood enters the ventricle, i.e. the heart, it causes them to stretch, which means there's an increased strength of contraction, i.e. the heart can force out more blood with each beat. That's what stroke volume is, isn't it? Stroke volume is the amount of blood that leaves the heart per beat. Well, with increased venous return, you're going to have more blood leaving the heart per beat because more blood is entering it, venous return is increased. Starling's law, all that is the ventricles stretch, which means it's going to make an even more powerful contraction. What you need to be aware of is, a question may ask you to describe the benefits of an increase in stroke volume. You can't just say, oh yeah, it means more oxygen going to the working muscles, we can work for longer at high intensity, delaying fatigue. You have to go through the whole process. So if it talks about how an increase in stroke volume is going to benefit a performer, you have to go through this whole situation, this whole kind of step here. Now you have to understand that stroke volume is dependent on venous return. So the whole thing starts with venous return. We get an increase in venous return, an increase in blood going back to the heart. This means more blood will enter the right atrium, because that's where blood enters first of all. This means the right atrium is stretched. When the right atrium is stretched, it increases the firing rate of the SA node. Remember that little node that's in control of the nervous control of the cardiac cycle or a heartbeat? So when the right atrium stretches, it actually increases the firing rate of the SA node, which means more blood is going to be forced down into the left ventricle. This means that the ventricle is going to stretch further, which is, i.e. increased ventricular stretch. This is going to increase the force of contraction, increase our stroke volume, the amount of blood leaving the heart per beat, increase cardiac output, the amount of blood leaving the heart per minute. This is called Starling's law. The whole net effect is it's going to increase oxygen to the working muscle, so athletes can work aerobically for longer at high intensities, lane fatigue. If you do not get this, rewind it and go through it again because it is important. Please answer this exam question. I'm not going to go through the answer with you. I am not going to speak it out, but I'm going to have it on the next slide, so pause this, give it a go. Here's the answer. If you pause this and get it down, mark your own work, make sure you've got everything in there. So decreased resting heart rate and decreased resting blood pressure, they were some of the other adaptations that take place. All it's saying is cardiac hypertrophy and an increase in stroke volume causes resting heart rate to drop. That's self-explanatory. The heart does not have to work as hard. Decreased resting blood pressure. Research shows that regular exercise can contribute to reducing blood pressure, particularly those suffering from hypertension. This improves our blood flow. Okay, so we just get an improved blood flow with a decreased resting blood pressure. Capillarization. Capillarization is increasing the amount of capillaries we have. We know that gaseous exchange takes place at the capillaries. Therefore, the more capillaries we have, capillarization, the greater gaseous exchange is going to take place, i.e. the more oxygen we're going to get to the working muscles, the more carbon dioxide we're going to remove. A better capillary network in the body will increase blood flow to working muscles. This allows for more effective transport of oxygen, nutrients, and obviously removal of carbon dioxide as well. Last one, increased blood volume. Blood volume increases as a result of capillarization. i.e. with capillarization happening, we get more blood. This means we can deliver more oxygen to the working muscles. It also means we can actually remove more carbon dioxide. And in addition to that, it means we can actually regulate our body temperature better, more efficiently, i.e. with vasodilation, vasoconstriction. Now, all that is quite a lot to get your head around, especially if it's a final question. It's asking for you to analyse the respiratory the adaptations of the cardiovascular system. We've got a memory method to give to you. However, you're going to have to bear with me, as I said at the start. Some of you will get it, some of you will not understand it at all. It's all about word association, okay? So you're going to have to write down on your piece of paper now the number 1, number 2, number 3, number 4, number 5, number 6, number 8, number 9. Okay, you do not need number 7. We're going to associate cardiovascular adaptations and respiratory adaptations together using these memory methods, because one of the questions that was answered in the exam was, please analyse the adaptations of the cardiorespiratory system. So that is the cardiovascular system and the respiratory system. What I've given you here is a memory method that's going to give you both. If it just asks you to analyse the adaptations of the cardiovascular system, you're obviously going to have to split up the cardiovascular and the respiratory ones to make it effective for what you want to know. So what we have is number 1. When you think of number 1, think of a home run. You think of baseball. When you think of baseball, you think of a baseball cap. Capillarization of the skeletal muscle. This is both a cardiovascular and a respiratory adaptation. Okay. Number 2 rhymes with few. Diffusion. Okay, we get an increase in oxygen carbon dioxide diffusion rate. That is a respiratory adaptation. 3 rhymes with wave. Okay, when you think of wave, think of tidal wave. Tidal volume increases. This is a respiratory adaptation. With tidal volume increasing, you then have to think of an increased vital capacity, increased pulmonary ventilation. All of those lung volume definitions that you learned can fit under that tidal volume increase. Number 4 rhymes with award. Award, you get a trophy. When you get a trophy, you get excited, you become hyper, you have hypertrophy, you have cardiac hypertrophy. That is a cardiovascular adaptation. Number 5 rhymes with drive. When you drive a car, you may crash. When you crash, you go to mechanic. You've got the mechanics of breathing. This is an increased strength of respiratory muscles. This is a respiratory adaptation that takes place. 6 rhymes with flicks. Flicks, you think of a flick knife, you think of stabbing someone, you think of blood, loads of blood, more blood. Okay, blood volume increases. That's a cardiovascular adaptation. Number 8 rhymes with mate. Another word for mate is a peer. You get peer pressure. When you think of pressure, you've got to think blood pressure. Blood pressure decreases. That's a cardiovascular adaptation. Number 9 rhymes with dine. Dine, you go to a restaurant, you order ravioli. The ravioli comes out, it is too small. You take it back because you want more of it. Bigger ravioli. When you think ravioli, it rhymes with alveoli. You get larger alveoli, and that is a cardiovascular and a respiratory adaptation. So right there, you have got both cardiovascular and respiratory adaptations. If a question asks you about either cardiovascular adaptations or respiratory adaptations, please try and remember 1, 2, 3, 4, 5, 6, 8, 9, and try and remember the word association that goes with it. Then you have to try and pick out which ones are cardiovascular and which ones are respiratory. Remember, respiratory is all to do with the lungs and the thoracic cavity. Cardiovascular is to do with the blood vessels and the heart. You can try and pick it out from there. obviously you then have to actually describe the benefits of more capillarization. So capillarization happening, more capillaries, it means you're going to be able to get more oxygen to the working muscles, more carbon dioxide away, which means the performer's going to be able to perform for longer at higher intensities. Cardiac hypertrophy, that is going to have an effect on our increase in stroke volume, an increase in cardiac output, a decrease in heart rate. Increased strength of the respiratory muscles, that's also the mechanisms of breathing, so we're going to be able to lift the cavity chest up further, get more air in, more oxygen in, and so on. Now for this whole section here, what you may have to do to actually understand why this is a benefit is you're going to have to look at the other PowerPoints that are on Moodle with regards to the adaptations of these systems. Okay. This was the final question on one of the exams. Analyse how adaptations to Suki's cardiorespiratory system could improve her marathon running performance. Cardiorespiratory is cardiovascular and respiratory in one. So what you have to do is adaptations for both cardiorespiratory system, how it's going to improve performance of a marathon runner. So what I want you to do is 1, 2, 3, 4, 5, 6, 8, 9. Try and get down the memory method. Try and understand it and then answer that question. Okay. Come back to me with regards to that answer. Thank you. Bye. There's the answer. I thought it was on here. Here's the answer. Just want to make sure. So get the answer down on there. It can be more than that if you've explained the memory method I've shown to you. That'd be perfect. Okay. Thank you. Bye.